We've all been there, waiting 5 minutes for a CloudFormation stack to deploy just to test a single line of Lambda code. It's frustrating, expensive, and slow. Enter LocalStack, the promise of a complete AWS region running right inside a Docker container on your laptop. It offers immediate feedback, zero cost per request, and the ability to code on a plane without Wi-Fi. It sounds like the ultimate developer productivity hack. But as many engineering teams eventually discover, this local convenience comes with a hidden tax. When your local environment tells you success, but your production environment says access denied or connection timeout, you've fallen into the LocalStack trap. Today, we're exploring why your local cloud might be lying to you and how to bridge the gap between local speed and production reality. The fundamental issue is the difference between API parity and behavior parity. LocalStack is a clean room implementation of AWS APIs, usually written in Python. It mimics the shape of the requests and responses, but it rarely mimics the internal constraints of the actual managed services. Take S3 eventual consistency or DynamoDB throttling as examples. In LocalStack, a put item followed by a get item will almost always succeed instantly because it's backed by a local database with zero network overhead. In a real distributed system, that same sequence might encounter propagation delays or throughput limits. When you build your application logic around the perfect performance of a local mock, you fail to implement the retries, backoffs, and error handling required for a noisy cloud environment. Your local cloud isn't just faster, it's unrealistically stable. Perhaps the most dangerous lie is the IAM Blind Spot. By default, LocalStack is incredibly permissive. It often ignores missing permissions, malformed resource policies, or complex service-linked roles. Developers get used to their code just working because the local environment doesn't enforce the principle of least privilege. Then they deploy to a locked-down production environment, and the application crashes immediately with a 403 forbidden error. Debugging IAM policies in production is a nightmare of trial and error that could have been caught if the development environment actually enforced those rules. Relying on LocalStack for security testing is like practicing for a marathon on a treadmill that doesn't have an incline. You're moving, but you're not actually preparing for the terrain. In your local Docker network, the round-trip time between two microservices is measured in microseconds. In a real AWS VPC, crossing availability zones or hitting a public API endpoint through a NOT gateway adds real measurable latency. If your application logic involves chatty API patterns, like querying DynamoDB 20 times in a single request, it might feel instantaneous on your machine. But in production, those 20 round trips add up to 2 seconds of latency, blowing past your API gateway timeout. Furthermore, LocalStack doesn't simulate the partial failure modes of networking. It doesn't drop pockets, it doesn't have DNS hiccups, and it doesn't simulate the cold start delays of Lambda. When you optimize for local performance, you are effectively optimizing for a world that doesn't exist. AWS moves fast. They release hundreds of features and API updates every year. LocalStack is a community and commercial effort to keep up, but there's always a lag. This creates version drift. Your Terraform code might work perfectly against LocalStack version 2.0, but use a parameter that was only introduced in the real AWS API last month. Or worse, LocalStack might implement a feature slightly differently than the official documentation. You end up spending hours debugging your local cloud infrastructure rather than your actual application code. Instead of offloading the burden of infrastructure to AWS, you've taken on the burden of managing a complex emulation layer. You've become a part-time LocalStack administrator, which is rarely what you are hired to do.
So what's the alternative? We don't want to go back to 10-minute feedback loops. The answer is a hybrid approach. Use local mocks only for the simplest unit tests of your business logic. For everything else, move towards ephemeral environments or dedicated sandbox accounts. Tools like SST, AWS SAM, or CDK Watch Mode allow you to sync code changes to real AWS resources in seconds. By testing against the real IAM, the real networking, and the real service limits, you eliminate the "it works on my machine" variable entirely. It costs a few cents more in AWS credits, but it saves thousands of dollars in engineering time spent chasing ghosts in an emulation layer. The cloud is meant to be distributed. Don't try to squeeze it all into a single laptop.